April, celebrating auspicious day of Ugadi and Gaudi Parva. Wishing you all happy Ugadi, happy Gaudi Parva. Wishing you all happy, prosperous, happy New Year. Today we have two sessions. First session is on 5G wireless network simulation in network simulator by Dr. Vetrivelan of VIT Chennai, followed by session on spectrum sharing by Sri Ashok Kumar Sir, DDG DOT. I take honor to introduce Dr. Vetrivelan Pandu, an esteemed academician and innovator in electronics engineering, currently serving as Professor Grade 2 and Assistant Controller of Examination ACOE at Vellore Institute of Technology, VIT in Chennai, where Dr. Vetrivelan plays a crucial role in shaping the academic landscape. In addition to his role at VIT, Dr. Vetrivelan is a key member of IoT and 5G working group in the Department of Telecommunication, Ministry of Communication, Government of India. Its significant contribution to the field are evident from his previous positions as program chair and head of the department at VIT Chennai. Dr. Vetrivelan's academic journey is marked by excellence, earning his Bachelor of Degree from University of Madras, Chennai, and later obtaining his Master's Engineering and PhD from Anna University, Chennai. With over 20 years of teaching experience across various prestigious institutes in Chennai, Dr. Vetrivelan has mentored numerous students, guiding several PhD candidates and more under his supervision. His scholarly work includes numerous publications, including book chapters, journal papers, and presentations at international conferences. Innovative spirit of Vetrivelan is further showcased through his involvement in patent filing. Beyond academia, Dr. Vetrivelan contributes extensively to various academic boards and committees, both nationally and internationally. Reviewer for esteemed journals and conferences. His research interests span a wide range of cutting-edge technologies, including 5G, 6G wireless networks, ad hoc and sensor networks, embedded systems, Internet of Things IoT, AI, data analytics, cybersecurity, and blockchain technology. In summary, Dr. Vetrivelan Pandu is a distinguished figure in the field of electronics engineering, embodying a commitment to the knowledge, innovation, and academic leadership. It is my pleasure to introduce him to you for today's session. I request Dr. Vetrivelan to take the session ahead. Vetrivelan, it is yours. Go ahead. Sir.
Yeah. Thank you very much, Mr. Sanjay ji. Thank you for nice introduction. Am I audible, Professor?
Yes, sir. Yes, sir. Yes,
sir. Yeah. Thank you. So, as the topic given to me, 5G wireless communication network simulations in Network Simulator 3. So, this is what the topic I will be engaging you for an hour. That is 10 o'clock to 11 o'clock. So, I'll just go straight away to the topic. So, in a nutshell, 5 to 10 minutes, I'll brief or recollect the concept what you had so far in terms of the context setting relating to the 5G. Then I straight away take you to the simulation environment. Professors, feel free whenever you wanted to interrupt and ask any clarification. I am happy to handle your queries. So please, any point in time, you can interrupt me. Moving further, so I'll take 5 to 10 minutes so to have a context settings. So if you look at with respect to the evolution of mobile networks, so we have a journey from 1G to 5G. So if you look at the analogy as a layman, so 1G is something like a speed, it's like people walking. 2G speed is something like a person running, and 3G speed is a person is using bicycle, and 4G something like a person is traveling in a motorcycle. With that is what is LTE. I think this onwards I wanted to have a deeper insight. So if you look at with respect to 4G, that is a predominant element, that is LTE, long-term evolution, and beyond 4G, that is LTE, that is a LTE advanced. So that network provides 100 Mbps when you are moving. When you are static, it provides in the order of 1 gigabits per second, and the latency in the order of millisecond, and the mobility it supports in the order of 350 kilometer per hour. So the kind of use cases like a mobile TV, broadband, and this is what is the general use case of 4G. But we wanted to have a something like a telemedicine or a robotic driven automation, as we have pointed out by earlier speaker, and three different group of use cases like EMBB and massive machine type communication and ultra reliable low latency communication. So that is what is the key principle of 5G. So if you look at 5G, the latency in the order of milliseconds. I think if you take 4G in the order of 10 millisecond, whereas 5G in the order of 1 millisecond latency. The upcoming 6G, it works in terahertz range, that is in the order of 300 gigahertz. So this is going to give you the latency in the order of microseconds. So I think this is what is going to be upcoming one. And everywhere we are talking about ultra what do you call ultra reliable low latency, and this is what everywhere with in the context of ultra. So if you look at with respect to this comparison, we have been keep discussing with respect to earlier speaker. I request participants kindly be mute, requesting you to be muted. If you have queries, you can unmute and ask. Otherwise, otherwise, Sanjay sir, can you mute all? Yeah.
Yes,
So
muted.
yeah, thank you, thank you. So I think if you look at with respect to 5G, we have a OFDM, that is a key funda. With respect to millimeter wave, we are using beamforming, carrier aggregation, lot of new features, the featured techniques we have adopted in 5G. So thanks to 5G, because of this adaptation, we could able to have a data rate in the order of 10 gigabits per second. So that is what is the data rate. And with respect to this works with both FR1 and FR2 frequency range. I think I'll take you in a quicker sense with respect to as the cellular communication generation goes from 1G from AMS, that is 2G GSM, GPRS 2.5G, 3G is about HSPA, and we have a so-called 4G is LTE, and LTE advanced, that is beyond 4G, and 5G we have a millimeter wave, and 6G we have a terahertz communication. This is what is about the cellular track. In the same time, we have a parallel growth track with respect to wireless LAN. We have 802.11. 802.11G is called Wi-Fi, which with thanks to OFDM, that gives on the order of 54 Mbps. But the limitation is the coverage area, only maximum of 300 feet. And we have so many hybrid. We have 802.AZ, 802.AC. There are lot of combo has come, the hybrid versions. So at the same time, we have a W panel, so like 802.15.3, and we have 802.15.4. So Zigbee, it's a predominant candidate to realize a lot of IoT applications. So this is what is kind of a roadmap outlook where we could able to realize both cellular as well as other wireless technologies as well with respect to the year of the origin as well as the data rate supported by the concerned technologies. So moving further, so let's have a quick focus with respect to 3G, with which we have a HSPA, HSUPA, DPA, and this is where we have a asymmetric bandwidth. You know, most of us are download stuff user, less uploading, so we need not keep equal passage for both uplink and downlink. So downlink we can keep more, uplink we can reduce the size. That is why we call it as asymmetric bandwidth capacity provisioning. We started that concept from 3G, and this is where the mobile broadband, we have a IP multimedia subsystem, IMS. We can have a both side camera, see and talk feature. All these things. This is what is the origin of multimedia supported mobile broadband. That is from 3G onwards. With respect to 4G, we wanted to have a faster internet broadband access. So that is what is the use case what we wanted to, we have realized through 4G. The 5G with respect to, as we have mentioned, RPA, robotic process automation, tactile internet, telepresence, and robotic surgery, telemedicine. Lot of use cases to realize we need to have a faster internet and broadband, low latency. That is what is the mission we are what you call looking forward. So that is what is currently we have realized 5G. So we are keeping a vision towards 5G. I'm sorry, through 5G we are looking for a 6G, and all these things are standardized by 3GPP, as we have a six different so-called partnership like ARIP, ATIS, CCSA, ETSI, TTA, TTC. These six telecommunication standards put together, they operate together in the 3GPP standard. That is what 3GPP. Earlier we have a 3GPP2 also during the journey of WiMAX versus LTE. So now everything is converged to a 3GPP. So now all IP principle. So that is what is the concept relating to 3GPP. So I'll just show you in a nutshell. So ETSI, European Telecommunication Standard, was one who actually standardized the GSM in the year 1980. In 1980, the expansion of GSM is Group Special Mobile. Only in the year 1983, this became global system for mobile communication. So by ETSI, and where we have a set up BTS. So that is what is controlled by BSC. We have a base station controller. This is called the BSS, that is a base subsystem. And when it goes to MSC, Mobile Switching Center, so then all other landline network, PSTN, and other data network get merged to this MSC. So where we have a core access air interface. So this is our handset user equipment. And why I am telling about 2G, you can see now with respect to keeping the red color existing 2G, and we have a 2.5G is about GPRS, where we have a origin of the internet data, that is GGSN and SGSN, that is gateway GPRS support node and serving GPRS support node. Thanks to these two elements, so we have a lot of other patching work as done in BSC to support the data access. So this is how later on we have a so-called BTS is no more BTS, it is called node B. So in UMTS, that is UTRAN, UMTS terrestrial radio access network. So like a BSC in 2G, 2.5G, where we have a radio network controller, RNC. This subsystem is called RNS, radio network subsystem. I think pink color, whatever I'm just demonstrating, that is a 3G. And we have a both circuit switching through GSM path and packet switching through UMTS pathway, and both exist. Both the packet switching and circuit switching was existing during the journey up to 3G. Later, I think we have a pathway towards 4G. We have everything all IP principle. And if you look at with respect to 4G with the green color, node B is updated form in 4G. It is called E node B, evolved node B. That is what is the layman term. That is a tower, and this is the user equipment. And we have a EPC consisting of packet gateway, serving gateway, mobility management entity. I think this is what is called EPC, evolved packet core. So this green color setup shows you the 4G 4G related aspects. So if you look at with respect to the pathway towards the 4G consisting of mobility management entity, serving gateway, packet gateway, and this is a policy configuration, what you call in terms of rule function. And this is a home subscribers station, and this is a eNode B, and setup eNode B. And we have a user, we have X2 interface, UU interface, S1 interface. These are all the several interfaces relating to LTE, that is with respect to 4G. Now I wanted to look into 5G, that is we wanted to realize the several use cases like autonomous driving, drone based delivery, remote health care, and tactile internet, AR, VR, XR driven use cases, IoT use cases. So all well connected use cases to realize the to handle all these things. The 5G is the predominant technology which support, and we wanted to have higher mobility with 300 plus kilometer per hour, and the data, it is in the 100 times more than the your 4G speed, much faster, and ultra reliable, low latency, energy efficient. So these are the demands for the 5G. So if you look at with respect to 4G architecture to 5G, we have a here EPC. Here with respect to 5G, we have a 5G core, and we have a here E node B in terminology in 4G. In EPS, we have a G E node B, that is a NR. So new radio, that is what is called the G node B with respect to 5G. So this is what is called the next generation radio access network with respect to 5G. We have a user equipment in 5G. All IP networks get connected to this 5G core gateway. So this is what schematic sketch of the 5G, and we have several use cases, as already the earlier speaker have spent a lot in terms of the emphasizing different use cases as well. So want of time, I'm just going directly to the simulation. So this is what is the 5G. You know, we have a maroon color. What I mentioned is G node B. That's a new radio, 5G new radio, the next generation core network, and the user equipment. And this is the user equipment in 4G. This is the user equipment in 5G. So this is what is the network architecture. That means system architecture with respect to 5G. I think earlier speaker have already spoken about control plane and data plane architecture of 5G core elements and other several steps. So I think I will not spend much time. I'll just as a quick recap. So we have a service-based architecture, network slicing, control plane and user plane split. So these are all the setup relating to 5G core, where we have a NEF, network exposure function, NRF, repository function, policy control function, unified data management, application, session, SMF, which is closer to MME in 4G. We have a AMF, that is access and mobility management function, authentication server function, user equipment. This is relating to user plane, other elements relating to control plane. So I think, you know, in a nutshell, we have a network slicing with respect to peak data rate and network energy, how many number of users per square kilometer, latency, spectrum efficiency, and these are all the tech specifications was already.
Hello, sir.
Hello.
Hello, sir.
So this is what is
Sir,
the.
can you highlight a little bit on network slicing?
Yeah, I'll just here we have a concept called SDN, that is software defined networks, as well as NFV, that is a network function virtualization. I think if you look at with respect to currently we have a CV2X, that's one interesting use case with respect to VANet, and where you know, cellular to V2X, we have a through NFV, that's network function virtualization, we can able to access several virtualized functions with respect to CV2X. That's a car, I think cellular V2X. That is what is one interesting use case in terms of the automotive sector. And we can have several other use cases also in terms of IoT based smart precision agriculture, and a lot of use cases there. I think I will be showing you through Quantity at the end. So so that is what is the, these are the concept components relating to network slicing. We have a slice selection function, slice instance, slice management function, slice controller, slice specific network function, NFS. So these are all the elements we get engaged relating to network slicing. So if you look at with respect to control plane and user plane, this is U stands for user plane, C stands for control plane. I think in this architecture, I mentioned about NSA as well as distinct 5G. Both this is going to work in a standalone in this side, and NSA with the inclusion of 5G, 4G EPS as well. So that is NSA system spec. So I think you know very well about the features relating to 5G. So we have a low latency in the order of 4G with respect to 10 millisecond, in the order of 10 millisecond. Here in the order of 1 millisecond, massive device because of IoT applications. We have enhanced mobile broadband download videos, virtual reality, augmented reality, extended reality, cloud gaming, network slicing with respect to various user groups, and beam farming, massive MIMO, dynamic spectrum sharing. Next session is going to be about DSS and edge computing. So to realize all these things, various security enhancement, energy efficiency, we have a lot of support with respect to 5G. and this is what about OSA layer. And I will be taking you to 5G simulation in network simulation environment
Hello,
3.
sir.
Yes, sir. So
Sir, these many features can be realized using MS3.
yes, sir. Yes, sir. Yes, sir. That's what I wanted
Thank you,
to.
sir. Thank you. Thank you very much, sir. Yeah,
Yeah,
fine, sir.
yeah,
Go ahead.
highlight. So we have a these two things is called application or service layer. Session and transport, we call it as open transport. Network layer has been split into upper network and lower network, and the data link layer and physical layer. This combo is called open wireless architecture. This is what is the generalized 5G mobile protocol stack. And as I've just discussed about so-called the protocol stack. I think this is about 6G. I will not go so detailed way in terms of 6G, because I'll just throw a light, because I in the NS3 I'm going to talk about TerraSim also, because that is going to work with respect to terahertz range. I think 6G in the order of 300 gigahertz spectrum, and we are going to make use of the spectrum to realize the latency in the order of microseconds latency. So I have a demo related to terahertz communication also. So I think 5G to 6G, whatever the current level what we are, that's beyond 5G. So we say 5.5G, or the general terminology beyond 5G. That is what I think. This is going to take at least 2025 to pronounce the standard. I think every 10 years only we have a standards. That's 2020 we have realized 5G, and 2030 we are going to set mark for the 6G. And if you look at with respect to this, we have a mission document in 3GPP portal, and a lot of people are working towards this particular IMT 2030 standards. We have a 6G Alliance, ETSI, IEEE, and a lot more jointly with the 3GPP. And if you look at with respect to 5G, we have a new radio, 5GC, 5G subsystem, and in 6G, this is going to be IMT 2030, and the 3GPP standard name is 6G, and the RAN name they have yet to finalize, even core name yet to finalize, system name yet to finalize, and the upcoming market would be of social entertainment, telepresence, and in healthcare, telesurgery, in automotive, coordinated time-aware tactile communication, and education, in-room presence, holographic haptic communications, autonomous vehicle, and a lot of these are the different verticals really will what you call rule the market in 2020 market window with respect to 6G enabled setup. I think if you look at in the use cases of 6G would be of micro broadband, micro precision, micro massive machine type, micro mobility, micro coverage, micro energy, with respect to digital twin, self-driving car, smart factory, smart city, and in-flight broadband. So I think with respect to robotics in the order of 6 degree of freedom, and extended reality, hologram, perceptual illusion, so live sports concert broadcasting, lot of use cases to have a fullest what you call way to realize. So that's what 6G is all about. This is about tech in terms of 6G in the order of 100 gigabits per second. So I think if you are currently 1 gigabit per second in terms of 5G, this is will be greater than more than 10 gigabits per second, more users, more mobility, and 1,000 kilometer per hour. Currently 5G looking for 350 kilometer per hour. That's what I want to tell. When you are inside the flight mode, even we could able to access the internet service, the spectrum efficiency 3 times more than the 5G, and energy 10 times more than that. So lot of things is to realize. So I think without spending much time, I'll be taking you to I think this is what is about. We have several unmanned aerial vehicle and satellite free space optical communication, as well as RF link, and we will have I think earlier several speakers have spoken about cellular structure. That is what is the funda related to this diagram. So every home will own their own cell structure. There won't be like a distributed cell architecture. So that is what is the pathway. So now I will directly start. I've set context settings. Now I will take you to simulation in terms of NS3. So is this fine, all of you? professors? Hello. Is
Yeah,
there any?
perfect. Yes, sir. Perfectly going on.
Yes, sir.
No
Yeah,
worries.
yeah,
Thank you.
yeah. Thank you. Want of time, I'm hurrying little faster. So if you have any query, you can ask me. So I'll go little slow.
Sir,
Yes, sir.
sir, you
Yes, sir.
take your own time comfortably. There is no hurry, sir. So
Thank you. Thank you. Thanks a lot, sir.
yes,
So
go ahead.
yeah, yeah. So I will be engaging you in terms of NS3 now. So if you look at with respect to this, I wanted to tell you a few things. Is this visible? My slides are visible?
Yes, sir.
Yes, sir.
Yeah, yeah. Thank you, process. So if you look at with respect to the various features associated with this simulator, this is open source. So what is the difference between free software and open source? The other category is proprietary software. MATLAB is proprietary software. We have to pay the licensing and we have to use them. So that is likewise, there are several softwares. So relating to communication, we have a so-called MATLAB. So to realize physical layer functionalities, to model physical layer functionalities, and to network level, we have several other tools like OpNet. So many other tools are there. So Glomosin was there for to realize 3G and the GSM, GPRS. Those things are long back stories. So this is come under open source. What is the difference between free and open source? So open source, we have a lot of community there keep working. So you don't have to pay. It is a under free category. At the same time, a lot of updates are freely available in the open source community. So like you and me can take whatever from this open source community and develop so much outcome, and you can deploy back in the same portal, so that other user will not do the same trial what you have done for a year or 3 months to bring out that fruitful outcome. They can take from your level and they can build something more on top of it. That's what is the key principle of FAST, that is a free open source operating system. So this is basically come under open source category, that is Network Simulator 3. So you can ask me a question. Do you have a Network Simulator 1 and 2? So we have definitely 2, but it is nothing to do with backward compatibility. So we have a NS2. There is nothing called NS1. The Network Simulator 2 was there. So people who have already worked with respect to NS2, basically it works with TCL script. You know, there are several script like Python script, Perl script, like a TCL also one such script. We normally write the configuration in .tcl, and backend we connect with the OTCL, that is a object TCL script through OTCL, through which we combine the object file and script. That is what is the concept related to NS2. This is very deprecated version. So what do you mean deprecated? So I think I remember at least 20 years I am in the teaching community in the similar domain. So I've used NS2 for to realize different routing and other things. Now we do not have a much support, and a lot of things are deprecated. We don't have a spectrum related to even 4G. We don't have support in NS2, and it is totally outdated. We can say obsolete now. So NS3 is open source. We have a lot of spectrum support relating to 4G, 5G, and even to have a 6G support, which is supported with respect to NS3. Even we can NS3 we can jointly work with MATLAB. Even NS3 we can jointly work with the Quantity to realize several IoT use cases as well. So this is the open source tool. So moving further, so this is basically, as I said, it is having a strong Python script support. So you know, Python is a powerful binding language. So this NS3 support Python script, like NS2 support TCL. Here this supports Python script, and it is also supports C++ for all the object oriented modules are written in C++, strong C++ with namespace support, and completely and C++ based one. And you can find every updates from www.nsnam.org. This is a non-profit organization. So from this link you can access NS3. I think I remember, I'm very proud to say this was there NS 3.2 9, 3.10, 12, 3.19. That was 10 years back. That during the time NS 3.19, that version I've used for my PhD work to realize heterogeneous mobility between LTE, UMTS, and Wi-Fi. That was using 802.21 media independent handover function. Using that, I have realized the soft handover 10 years back. So I've used NS3. Currently, we are with the NS 3.41. So please underline. So currently, we are with the NS 3.41. I'm keep tracking of all the updates. If you look at NS3, even support 802.11p. What is 802.11p? Wave support. Wave stands for wireless access for vehicular environment. It supports even relating to. But currently, earlier we had 802.11p with the DSRC. Currently, everything is now with cellular V2X current module, that is a NS 3.8. Up to that we have a wave. Later that wave become obsolete because we started to use cellular V2X. So we have a LTE based V2X concepts. That is what is the support now. I think if you look at why do you want to go for simulation? Is there any justification to say why do you want to go for simulation? Why not direct deployment? Is there any answer from participants, professors?
Sir, to realize the difficulty of installation, simulation helps us to get the results, and then based on that, we can go for deployment.
Yeah, thank you very much. Because we cannot afford to spend so much in direct deployment. If it works fine, that is okay, well and good. If not, we have to again we have to buy, procure, and we have to configure and do a lot of trials. That is not advisable. Normally, we go for modeling the problem, then simulate through simulation. You thoroughly verify if it is works. You go for prototype. In prototype level, we just strongly we do redefine, and we get the expected results, then go for bulk production. That is what the same way this environment strongly supports all modeling, and you can able to thoroughly validate the works. So this is, I think, as I mentioned already, NS2 versus NS3, it has got a lot of scalability, and it supports cross layered of support. It support tracing .tr file, pcap file, that is a packet capture file. Lot of supports we have. It supports both IPv4 as well as IPv6 stack. I think the researchers, those who want to work with the IPv4 and IPv6, and even it supports 6LoWPAN, which is a very predominant layer in IoT based use case. So 6LoWPAN support also is there, and it is having integrated support to have a Wireshark, pcap file, and even trace metric. Lot of supports we have in this particular NS3, and the overall organization of the model of NS3 layers, we have a core network, core layer, and where we have a with respect to various callback, logging, random variable, the network where we have IPv4 and as IPv4 stack, various mobility model, the internet stack, there are devices, and top of that we have a helper, holder, and we can write several use case applications on top of it with a .cc file or a .py file, Python file or a CC file. This is what is the hierarchical layer of NS3. And if you take NS3 various classes, as I said, NS3 supports strong object-oriented programming. So the nodes, we have a nodes are called computer, end system, host. Applications can be a TCP driven, UDP or CPR, variable bitrate, and the different category of application. Channel, we have a Wi-Fi channel, CSMA channel, and with respect to P2P, point to point, and with respect to channel related to WiMAX channel. I think I wanted to tell you, even WiMAX support we have. I think you have a 802.16, that is a IEEE standard for WiMAX. That is also a predominant candidate. I think during the competition between LTE and WiMAX, so WiMAX also a stronger candidate like the LTE. LTE has got lot of backward compatibility. That is why that become the winning candidate in 4G race. For WiMAX, it is having lot of backhaul support, and a lot of we have a support in NS3 to realize WiMAX related applications as well. We have a net device, container, and helper. So these are all the classes to handle the different components. I think if you look at the conceptual view, the application, protocol stack, the packet, net device, we have a channel, wired channel or wireless channel. Similarly, the receiver, the reverse direction. This is the conceptual flow. I think if you look at the detailed way, we have application. The socket, basically it works with the socket function. Hopefully, some of the professors might have handled a course network programming, Unix socket programming. Correct, professors? Aware of?
Yes, sir.
Hello?
Yes, sir. Yes,
Yeah.
sir.
Yes, sir.
So the socket communication through which send to receive from, if it's going to be UDP socket, if it is a TCP socket, we have a so-called concept called connect three-way handshaking, the accept function. That is how the three-way handshaking, the data exchange. We have a close and shut read, shut write. So that is what is close. So we have a four-way handshaking for a connection termination in terms of TCP. So all these things to realize this is how the general stack of the implementation. And if you look at with respect to example, this is what include NS3 core module. As I said, core, network, internet stack, point to point, and application. This is what is the layer related module. We have to include the related headers. Then it support namespace, and we have a component defined. I think if you look at with respect, as I said, node container is the class, the instance is object nodes. So I create two nodes, one for transmitter, another one for receiver. Are you all following process? Because of time, I may be rushing. So because with the sample example, I will just explain. Then I'll go directly to LT code. So
It's fine,
this is
sir. It's fine, sir. It's fine, sir. It's
yeah.
nicely go ahead, sir. It's going very fine. Yeah.
Yeah, this is a point to point object. So this is a point to point helper class. This is object name. So we do set data rate, that is with respect to 5 Mbps. You can do settings. I think I'll show you similarly with respect to how do I set 1 gigabits per second for LTE. If it's going to be a so-called terahertz communication, I will set uh, more than 10 gigabits per second or 100 gigabits per second. How do I set for a terahertz communication for 6G? So delay in the order of milliseconds with respect to 4G 10 millisecond, 5G is in the order of 1 millisecond. So this is about Wi-Fi link, I mean wired LAN. So I'm just installing all these settings into the node, into the devices. So if you look at, this is how we have to create the topology. This is for base IP address for IPv4, and we have a I run the simulation between 1 second to 10 second, and this is what is about the server code. Similarly, we can write a client code, and we can able to run, and we can able to see the demo like this. So I will show you how this could be executed. So I'll just show you in a quick way how to install this particular NS3. So I'll share all the documents to you through Mr. Sanjay Madhukar and his team. So they will share all the steps. I think want of time I will be initially, I think as I said, we have a nsnam dot so-called org. That is where the site from where we have to download the source code. I think you can see www.nsnam. Can you see my screen? nsnam.org. Able to see,
Yes, sir.
professors?
Yes, sir. Yes, sir.
Yes.
Yeah.
Yes.
So the Network Simulator 3, it's a free open source. You don't have to spend even a single paise. So in clicking on download, it will take you to the download the so-called, I will not go in the same flow. You can see NS 3.41. I told you, I'm proud to say I am keep tracking of all the versions. So from I think even older versions are there. So currently we are with the NS 3.41. So I think a month back only this 4.1 has come. So I have installed NS 3.40, which is a stable version. So I'll show you that is what I have installed, and by going through the step which I have shared right now. So with respect to this step,
Sir,
so
this software is can be installed in Windows or not?
yeah, it is a very good question. It's a Linux support. We can work with Linux separately, or in Windows you can put any Oracle VM player, and you can install this. That is possible. So
Sir,
if you are
version must be Ubuntu 22, sir, or lesser than that is okay.
even lesser than also is okay. It's not, if it's 22, it is well and good,
Ubuntu,
because you will,
Ubuntu 14 onwards it works, sir.
yeah, it still works. But if you look at with respect to upgrade to 2022, you will get lot of package supports. That is why I'm telling you, work with the 2022 LTS 22.04. That is a version Ubuntu. That's you will have a lot of GUI support. I think it's interesting. Lot of participants are interacting. So thanks to because I'm also one among you. So I have nothing to hide. I'm not from industry. So you can ask any questions any point in time. So NS all-in-one 3.40 inside. So this is NS 3.40. So if you look at with respect to, I'll just execute the simple code which I've shown inside examples. So we have several tutorials for beginners. If you see first.c, this is what the code which I've explained already. So if you take the settings which I done, MBBS of 5 MBBS, 2 millisecond delay, IPv4 setting, and simulation going to run between 1 to 10, the payload of 1024 bytes. So this is a sample code. I think once you install, you will get everything. So you don't have to worry about this code and all. So I will be executing this file. So I will open the terminal. Are you all following process?
Yes, sir.
Yes,
Yeah.
sir. Yes,
Yes,
sir.
sir. Yes.
Yeah, open
following.
open the terminal. So my terminal is visible, black and white window.
Yes, sir.
It's
Yeah. So present working directory. So Vetrivelan. This is where I'm currently. I'll go cd ns all in one 3.40 ns 340. So please understand. So this is what the location I'm accessing through command prompt. So SRC, if you see source, you will see antenna. Those who want to work, lot of support in antenna with the MIMO, EODV, and with respect to LTE, 5G, LENA, what you call low powered W band, 6 low band, WiMAX, Wi-Fi, all the what you call AEZ and other combo with respect to the DSD, DSR, energy driven, open flow, and a lot of use cases are there, the, various propagation model. So these are all the several existing source code. Suppose you, as a researcher, you want to create your own folder, you can create your own folder, and required source code you can keep and you can deploy. That is also possible. So like that only I have done separate entity, something called inside the contrib. So Terabytes T is a TeraSim I've installed. Inside this also we have several models. So I will be showing you all one by one. So I am just taking you to the terminal. So this is where I'm currently. So I have to execute /ns3 run. This is the, I think all, I'll share all the steps to you how to run. And I am currently examples tutorial first.cc fircc. So if I put enter, so I think can you see at 2 seconds client send this data to this at port number. This is a simple demo. Are you all following
yes, sir.
process?
Yes, sir. Yes,
So
sir.
this will create TR file, trace metric, and even PCAP file, packet capture. So a lot of things this will be going to create. So I
Sir,
will
and the
be,
channel is point to point.
yes, point to point. In this case is point to point, sir. You can
Yes.
configure to many other things also. So I think same way, one tutorial I want to tell you, create nodes and facilitating communication between them in point to point. So how to make point to point. So here you have to add point to point module.h. Then when it comes to create a nodes, and you can have a LAN or point to point or Wi-Fi, different types of nodes you can choose, and you can choose the data rate and delay of the particular channel. And this is a point to point device. So this is the same way you can, I think one interesting fact here is you can enable point to point dot enable PCAP, packet capturing all. Have you heard about Wireshark? Like Wireshark, we can have a dot PCAP file also, TR file and PCAP file, because you can explore the PCAP file and you can plot the GNU plot, and lot of supports is there in this tool. So I think I will not spend much time in basics. So that's the reason I'm not running connecting two different types of wired network. So you can even connect two different types of wired, one Ethernet, other frame relay or any other networks. So you can do that also. So you can even wireless node, 100 nodes you can deploy, and you can use it for some precision agriculture or any other application. So that is also possible. Here I have created 10 Wi-Fi nodes, and we have with the different routing, AODB or DSR, DSDB, or in you can change the routing. You can do the analysis of the routing performance. That is possible. So you can do the manage
Sir,
mobile adapter.
in previous slide, you have used this OFDM concept.
Yes, sir. Yes, good question. And when it comes to Wi-Fi, we have a called OFDM. So can you see, sir? I think I have a something called YANS Wi-Fi channel. This is what is relating to a physical layer of Wi-Fi. You know, thanks to OFDM, because of OFDM, we have a 54 Mbps in 802.11g. So we have used OFDM modulator only in this
Okay,
scheme.
sir.
So can you see, sir? Data rate, string value, OFDM rate of 54. Hello.
Yes, sir. Yes, sir.
Yeah.
Yes,
So
sir.
we have that support. So you can use the same OFDM module, a separate module. It is engaged to with Wi-Fi. The same is engaged with the cellular 5G standard as well. So you can use
Sir,
them. Yes, madam.
sir, if I want to change the channel, suppose in the code, how to do it?
Yes,
There
madam.
is something.
Yeah, you
Suppose this is Wi-Fi channel. Set Wi-Fi
yeah.
channel is giving. Now I
Yes.
want to change the channel. Then
Point
how
to
to
point.
do it?
You have a class name called P2 point. You have to create the instance to a object for that instance, ma'am. Instead of Wi-Fi channel, can you see, ma'am? Wi-Fi helper,
Yes,
Wi-Fi.
yes,
So
yes.
you have to use point to point
Okay.
link or
Now point to
related.
point, and on my own, something new on my own. If I want to create,
Yeah, you
can
can
I create
create.
it?
Yeah, you can create a source file inside the SRC folder, and you can create object for that also. I think you
Okay.
know how to create a classes in C++, right, ma'am? You can
Yes,
create
yes,
a
sir.
class name, and same style you can follow, and you can create your own methods and members inside the class. The instance you can access here relating to the network related. Hope my
Okay, sir.
point is clear, madam.
Thank you, sir.
Yeah.
Yes, sir. Thank you, sir.
Yeah. So we can enable different routing like wireless or different other AODV. So different things are possible. I'm just, because these are all basic, that's the reason why I'm running faster. So you can do simple client server. You can implement chat application. You know, WhatsApp, single chat, multi chat. So you can try all these things as a simple emulation, or you can assign these tasks to or simple mini project to your students also. So the students are nowadays they're all techie kids, and they can grab a lot of information from open source community. They can do a lot of applications. So this is a use case related to single chat, or you can use TCP with the multi chat also. That is possible with the TCP variant. One group with voice chat, one group with video streaming. All these things are possible, and that is possible to realize. So I think I've just given only basics here. Now I will be taking you to the so-called there is a folder called scratch folder. This is where all your working files you have to or your development you have to try all these things. So one such entity inside this is because of, as I said, I've informed you NS 3.40 inside SRC. There is something called LTE. Can you see? Hello.
Yes, sir.
Yes,
We
sir.
can see.
Yeah.
Yes,
Please
sir.
go ahead, sir.
Yes,
Please
sir.
go ahead. We are able to see.
Yeah, thank you. So you can see there is a folder called LTE. Inside LTE, there are several models are there. So if you can see, have you all heard about EPC, Evolved Packet Core? Even with 5G NSA, the 4G EPC eNode B and MME, that EPC setup will work jointly with the G eNode B also in NSA. Only in standalone, the 5G millimeter wave will come into play. So if you look at this is a 5G LENA, we have a EPC and LTE related code, related models, and different fading different channel model, everything is there. So if you look at with respect to examples, this is what simple example, Lena simple
Sir,
EPC.
here, which are all the only 5G components?
Yes, this is LTE is basically a millimeter wave supported beamforming supported LTE module is this. This is a LTE folder is the 5G related support, sir.
Okay, it means that, sir, it's not only 4G along with 5G. It means NSA only.
Yeah, NSA. Yeah. So if you look at with respect to this is basically LTEA. So if you look at with respect to fading, you want to explore. If you want to explore, let's say I will open up this simple Lena. What I want to tell you is this is the file source file. I just you can even copy, right click like this way. You can right click copy and take it to the development environment. The scratch is the development environment. I just right click and paste. So that is how I pasted Lena simple EPC. So this is the Lena simple EPC. So is this my screen is visible, professors?
Yes, sir.
Yes, sir.
Yes, sir, yes, sir.
Yeah. So I want you to understand. That's the reason I was telling you the entire stack. This is the header file, application, configuration, store, core module, internet stack, LTE. There is a LTE module.h, which I said the module inside we have several header files that is getting included here. Mobility model, point-to-point model, net anim. So I am going to use animator. So that is why I included netanim.h, net animator. So this namespace ns3. So when you want to get through command prompt, number of enode b, can you see the number of enode b, number of user pair? Let's say I put 20 enode b. So I want to put 10 pairs. So you can you see you can have your own configuration. So you can get number of enode b, number of UEs, total time duration, distance between enode b's, and you can what you call enable disable different things. So that is possible. So that is what is this command prompt is all about. Now when it comes to I
Sir,
have
how
a
to differentiate here with LTE and 5G, sir?
so
Here,
that's
I
what
mean, few things.
so I will show you with the millimeter waves separately. So now I'll talk
Okay.
LTE. So I'll show you millimeter wave also in a moment. I think that is there in my so-called. Uh, I have Windows there. I put so-called VM player. So there I have there I'll show you, sir. So let me finish LTE here and the Terrasim. Then I will switch over to Windows and show you the there, sir. So if you look at with respect to node container, how many nodes you want to create, and point-to-point helper, and you can set the 100 or 10 gigabits per second, and with respect to the millisecond, 10 millisecond or 1 millisecond, and you can install the node in IPv4 stack, or you want to change it to IPv6, and you can mobility constant position or appropriate mobility model you can uh, call. So please understand this is the existing code. I will just quick simple some ports and all. So this is what is the sample code. Please underline. I've enabled ASCII trace helper. So I've enabled trace file. This syntax I've added so to trace because it will generate a trace file called 5G trace.tr. The trace file I'll open and I'll show you how to analyze the output. This is one way is trace. Another way is through animation we want to see. Animation trace is the class file. The anim is the object. So 5G millimeter 5G sample is something you can put 5G sample. I think millimeter wave I'll have it separately. So this 5G sample LT based XML. So this is what I have added. So then simulation, what do you call simulator run. So this I will compile and show you how to compile this. So I will I think you have to put a gedit. Through the gedit also you can do Lena. This is what I have been telling. I may need to put sudo. So it is a sudo permission. So now I've just edited. So I will be running that ns3. So it is there in scratch folder, scratch Lena. I have to run ns3. This building the. So can you see this? So I have just executed. Now I have to go and see the trace file. Can you see this? What is the name of the trace you have given? 5G trace.tr, 5G sample XML. Are you all following process?
Yes, sir. Yes, sir.
The
Yes,
trace file, you can see at the 0th second which node what is communicated. You can move this in a separate file also. This is a trace file. You can write a separate script to extract information what is required as a researcher to plot, and you can publish your work related to your model. This is about GUI because it's XML file. I'll be running this XML file. So I think you can open with the Wireshark also. So command prompt, through command prompt you can please remember, I have a trace file, I have a XML file. So this XML file I have to open. I have something called inside ns3. I have a netanim. So can you see netanim? So inside the netanim folder, I am just opening net animator. Can you see my screen process?
yes, sir.
Yes,
Yes,
sir.
So
sir.
I can go there, open the so-called inside NS. This is my working. I think you can see 5G sample XML, which I've renamed. That I'm opening, and you can run. I think, can you see the nodes are communicating?
Yes.
Yeah, this is the simple way you can realize the an animation based output. So the TR file is one way. You can plot the graphs also. So I will be showing you in a moment. So before that, I have another use case inside a Scratch. So I've done something related to FANET. Have you heard about MANET process?
Yes, sir. Mobile ad hoc networks.
Yeah. So FANET stands for Flying Ad Hoc Networks. So this is for to implement drones, inter-drone communication, drone to ground station. So we have done 802.11 P-based stack related to VANET. So we have done for so-called simulation related to FANET also. That too 3D emulator we have done. So if why I'm showing this now? So we have animation FANET 3D XML. We have already executed and created. So you can even rewrite and create also /ns3 run inside a scratch folder. So there is a fanet.cc. So if we running this, it will generate, because inside the code I have already shown inside this code we have a name of the trace file is fanet3d.xml. This is a so-called your XML file for animation, fanet3d.tr. This is a trace file. So do remember the names, whatever I'm just telling you. So why I'm telling this now? Because inside this you can see all these things. So can you see fanet? So fanet 3dtr, fanet 3d.xml, all these things are loaded here. So you can, same way net animator, you can able to open up and you can realize this GUI of fanet also. So same, double click, open this. I think in this location, inside this you have a FANET XML. This is related to, I think you can integrate this with Sumo. You know Sumo? Hello?
No, sir, no.
Yes, a little bit.
Yeah, VANET related suburban multimedia mobility model, because you can take open street map OSM, so you can take your own locality road map and integrate. You can make your vehicle to do autonomous route vehicle driving also. I think all these things are possible to integrate this with the Sumo, and that is possible. I think I will be opening.
Sir, this how to integrate Sumo and NS3. I know that is not in this tenure it is not possible to discuss, but
Yeah.
you may share your views some other
Yeah.
time how to integrate the Sumo and the NS3.
Yeah, definitely, ma'am. So this is the FANET which I've shown. How to measure the performance of these things. Let's quickly see. We have various ways to measure the performances. Can you see whether my slides visible? Process.
Yes, sir.
Hello. Yeah. So there are many tools to explore the output of the NS3 file. You can use general Wireshark, name, trace metric, ASCII trace file, packet capture file, pcap file. C is missing. I'm sorry. Pcap trace file, flow monitor, GNU plot. So I'll just show you the logic. So Wireshark is a simple capturing tool. You can do a lot of analysis. Who's the source? Who's destination? What is the packet? What is the packet error? So many things you can analyze with the Wireshark. It's a very layman tool. You can install using sudo apt-get install Wireshark, even in Linux environment or in a Fedora environment. Fedora and Linux, the command-wise different. Here you have to use install. Here also install, but here you put apt-get. Here yum install. Yum install. That's how you have to install in a Fedora-based machine. This is Linux Ubuntu machines. So I think name, the one which I said, you can separately install, but NS3 comes jointly as a byproduct. It is comes integrated way name. So whatever I said, I've already added the header file name module.h. This I've added in the header file. I remember animation interface anim. I put 5G sample XML. This will generate a animation file. You can integrate and run. Trace metric. I think I will be opening and running the trace metric Java jar trace metric.java. So if can you see here, I have a trace metric. I have installed something called trace metrics here. So you can, this is having a jar file. This is a jar file. So are you able to follow my screen? Process.
Yes, sir.
Java hyphen. So as I mentioned here, Java hyphen jar trace metric. That is a command. This will open trace. Do you remember trace files we have generated? Choose a file. Where we have got process, where we have got this trace file. Please respond. Inside a NS 3.40, inside 340. So I had created 5G trace. Can you see the trace? 5G trace, FANET 3D trace.
Yes, sir.
So
Yes, sir.
this trace you can open. So can you see these many packet, this many queue, this is these many dropped. My simulation time is this, like that. Even you can analyze. I have a 0 to 56 nodes. This is my throughput. This is my stream. These are all the UDP packet. All these analysis you can do with this jar file. That's a trace metric. Professors, are you all following? I think I have a lot of content. That is why
Yes, sir. Yes, sir.
packing you. At least I will introduce to you all the terminologies at least. So this is a trace metric. I think you can upload more than one trace file, and you can do joint plots also. That is possible. ASCII trace, this is the command to create a trace file. So that I've shown. So you can even analyze the pcap file. There is a command pcb dump. So you can take this through command prompt. So I have to keep ls. I should know pcap file. Can you see? I have done earlier panet 3D pcap file. So I will open up and take that. The file name of the pcap is, let me put pcb dump space -nn space -tt space -t. I will put panet because so many panet 3D simple. Any other trace file is there. So I will execute small, yeah, I'll put dos attack dot trace file. So I have to put sudo concourse file. Maybe that is having some issue, some syntax error. I think that is the way to I'm sorry, you have to put a pcap file only, not trace file. Are you all following? Process, are you all following?
Yes, sir.
6-0 dot pcap. So I think we have to generate pcap correctly. So that is what related to the pcap you can trace. There is another interesting component called flow monitor. You can monitor the flow of the data. So I think in the simulation file you have seen simulation : run. Before that we have to put these installations, include these things before that line. Obviously you have to install add includes and other declaration. After the run you have to use this instance. That is a you can create a flow monitor. So you can use this xml file using name. You can even monitor. So I think visualizer is the deprecated one currently. So I think these are all the concepts. Even you have a gnu plot, how to plot gnu.
Sir, all this comes along with NS3 package only.
Yes. So you can install ns gnu. You can install sudo apt-get install gnu, and you can set terminal png file output to file name. Set this. You can put the data that will plot a gnu plot, like we are putting in excel. We are plotting, no, likewise you can put a multi-plot. All these things we have a support in ns3. So now coming to the concept of ns all-in-one 3.40.
Sir, now based on your experience or your expertise, what are all the things or the issues of 5G can be addressed using this NS3? I mean,
Yes, sir.
some sort of.
As I am trying to say, we have a antenna design work you can do. You can work on propagation, lot of propagation related issues there. You can take up those challenges and you can work antenna. We have a MIMO. On top of that, we have a lot of concept like beam forming, carrier aggregation. So these stuffs related work you can do here. Propagation related work you can do. Use cases, if you want, you can work with 6 low pan and LTE. And the now coming to researcher aspects, if you are wanted to go relating to 6G, want to trace. So I have a full, I think, why do you want to go for 6G?
Sir, actually, realizing 5G use cases, what are the different things that can be brought in this instead of going for
And
6G?
very simple latency wanted to bring down to a microsecond delay. So therefore, frequency in the order of 6G. Definitely, it is not in the FR1 and FR2, right? It will be other region, right? Agree?
Yes, sir. Yes, sir.
Yes. So it is in the terabytes, terasim. So here also we have a. If you look at examples, we have a macro and a nano. I think you all macro, central, nano, adapt. So this is what is the deployment style, macro and nano. There are two different modes to
Sir,
work
have
on.
you realized any sort of applications with 5G healthcare with respect to this 5G
Yeah,
simulation?
application is lot, sir. So if you could understand the terabytes, this is a physical layer, terabytes device, nano mode, you can see nano physical layer, nano mac layer, protocol stack, physical layer, mac layer. These two are very funda relating to communication. On top, you can build any application. This model related to terabytes physical layer, and there are two different, one is nano mode and other is macro mode. Can you see, sir? Macro, Mac,
Yes, yes, sir. Yes,
Nano,
sir.
Mac. There are two modes. Terabyte spectrum propagation. So physical layer, energy
And these
model.
are all associated with 6G only, sir, right? Sir?
Yeah, these are exclusively for 6G inside a model. And application, I have two sample application. One is macro central, another is nano. So
Yes,
you
sir.
can you can, I think one of the file I brought inside a NS all-in-one 3.40. There is a folder called Scratch. Inside Scratch, can you see terabytes nano adapt file? I brought it here. So I will be opening and are you all following?
Yes, sir.
This is the CC file related to 6G. So you have a support related to terabytes. Similar style, but the concepts are, you need to go deeper and you have to take a insight. So in this case also we have done sample from
Yes, sir.
this microseconds to this. So if you look at with, I'll just execute and show /ns3 run scratch terabytes. So I think if you could understand the throughput and other things are here also, you can enable the packet trace and you can create a animation file. Using that TR file and anim file, you can do post execution analysis that is possible with respect to this. And for IoT use cases relating to 5G, if you want to work on, there is a separate tool called Quantity NG. That is, we call it as Quantity Next Generation. So I think that is going to be in a separate session, because already I've taken a lot of time without his permission. I borrowed a lot of time now. So there is another tool, Quantic NG. Here you can do a lot of use cases relating to 5G use cases. This is exclusively IoT environment for constrained devices. This is separate entity. Whatever I've shown, NS3 is separate entity in terms of simulation.
Sir, please
So
run this one, contact NG and show, sir.
that is also Linux environment, sir. So I think if we have separate session, we can plan for Quantic NG how to work with use case development, because that is again a real-time operating system for IoT devices. So I think we have done a lot of applications related to that. If I'm not wrong, I will share my location where I have done a lot related to Quantity NG. So different use cases. If you remember, terminal based Kuja, we have integrated. We have created a virtual sensor like a nuclear power plant. You know nuclear power plant principle, sir? Hello?
No, sir.
Nuclear
No.
nuclear power plant, the nuclear fission, the enormous amount of heat that you can use them to convert water into steam. that steam you propel over a turbine. Turbine will rotate, generate electricity. So we are all lacking nuclear experts in India. So therefore we are depending on Russian expert. So we keep all the sensor, virtual sensor in the. I think nuclear power plant you cannot, human being can go directly and do the reconfiguration because you have a moderator and all these things are nuclear reactor. So you cannot. It is very hazardous zone. So you can keep sensor and you can keep all these value sensor are virtually available in dashboard to the Russian export. They can sitting in their terminal, they can do reconfiguration. That is what the real power of Internet of Things based application. So you can, I think we have done similar application using virtual sensor through IPv6. We have demonstrated that on sample example. You can use QAP. QAP is a constrained application protocol, and we have MQTT. So a lot of things are there. I think I cannot dump everything in a 1 hour session. So I think whatever the best I can demonstrate. So I think I've demonstrated. So even NS3 itself with a wireless environment, MANET, FANET, separate and vehicular adapt network, separate group, cellular separate group, and 6G separate group. Lot of things you can realize. So I've just given you like eye opening for a academician. You can keep working with the NS3 and the Quantic NG. All are open source. If you have any questions, I can take it up.
Sir, excellent presentation. Very good presentation within very less stipulated time. You have given so many things. We are really thankful to you, sir. And I have one simple question, sir. Like, what sort of 5G applications are the sort of issues that can be given to set of students to use this NS3 and to come up with some set of results?
A very good question, sir. We have tried to demonstrate drone-based medicines delivery, sir. So that we have tried. What happens now? We have developed the model in NS3, but the application-wise in Quantigi, we have bought micro, wireless sensor network concept, sir. Moat.
Yeah.
We have a tiny moat we bought and dumped the executables inside. As a node means a computing node with antenna, battery driven, autonomously it will operate. That we have integrated with the drone. So with appropriate 3D so-called mobility model we have deployed. So as a prototype we have demonstrated. That is the work.
What other tasks simulation wise we can give in 5G for students, sir?
Yeah, simulation wise you can do exemplary very high level simulation also possible in NS3, sir. Terahertz level support. I don't think so any other open source free software support provides this much level. I think even MATLAB they don't have that much support for as of now. They may maybe next version they may upgrade. So I'm not against MATLAB, but at the same time, I'm not against any of the proprietary tools, but for open source, it is available. As academician like you and me can sit in our home, you can build a lot. We can make our students to do thorough simulation. I think thanks to government, they have given a 5G use case lab. All these thorough simulation, you can take it to the field using the components, whatever they are going to give us. You can realize telemedicine. Telemedicine is one such an interesting use case where you can think of in 5G and 6G environments, sir. That is also another use case.
Agriculture, sir? How about agriculture?
Yeah, that is also interesting. I think we have done last year one capstone project for precision agriculture. I think it's a good question. We have so many uncultivated lands left out in India. I think Dr. The Narendra Modi ji objective to convert through all these 5G use case, smart precision agriculture, we can make uncultivated land to be a cultivated land. Then thereby you can increase the GDP of your country. So by technology driven support, we can give it for the farmers. I think we have done some work in terms of. I think I have something to share. I don't mind in sharing because I'm basically an academician. So we have done something for smart agriculture, for smart farming. If you understand, I think I have one simple sample I think in southern part we are popular in rice, that's paddy farming, sir. We have two different groups of land. One is called dry land and wetland. For paddy, we need to have a wetland. For a groundnut, that's a dry land product. We don't need to pour water all the time. I think this is a good use case to discuss in this forum, because from state Andhra Pradesh to till West Bengal, different state in NPK proportion we have analyzed, and which particular state, which particular the NPK proportion, the nutrient. We have done a model for a nutrients deficiency related metric or disease related. So a simple farmer can take an image and understand what nutrients deficiency this plant. This is a groundnut. Those who are from southern region, you understand this is a dry land product. I mean farm. This is a groundnut. And if you take other one, this is a paddy. Taking image and submit it to the as a photo. That app will in turn having ML model which will integratedly work. Will find what is the deficiency, as well as it is going to tell what disease also. There are two variant. This model work. One identifies the deficiency level of NPK proportion, and another is what disease. So appropriately, you can help the farmer to add appropriate fertilizer if it's a water nutrients deficiency is clearly indicated, or if what the disease, you can put appropriate pesticide so that they can able to safeguard their plants. Thereby, they can increase the yield. In turn, you can provide a technology-driven support. That is what is the motto. I think certainly I have answered your query, sir. I think in the north part you can.
Thank you very much, sir.
So
Thank
if
you.
you have
Thank you
any,
very much, sir. Thank you very much. Yeah.
thanks a lot. If you have any other questions related to network side or any other one or two, I can take it up, because already Professor Ashok Kumar Ji is already waiting. Professor, is there any other questions?
Yeah, I have two questions, Professor.
Yes,
One
sir.
is, any of the
Any use
industries
case on
currently
autonomous
using?
vehicle, communication between autonomous vehicle?
Madam, one at a time. Sir is asking first. One at a time.
Yeah. Any of the industries like Qualcomm is using NS3?
Any use case on autonomous vehicle? Any
Yes,
use case on autonomous vehicle, sir?
Sir, Qualcomm, with respect to physical layer related, they are using NS3 for not only Qualcomm or other industries. There are several other industries they are using NS3 for their pilot run. After that, only they go for implementation.
Okay, and that is the first question. Second question is, wireless environment is highly dynamic.
Yes, sir.
In that case, how this kind of simulation will be useful?
Yeah, very good question, sir. Because terrain mobility model, and we have a very strong mobility model. Earlier days we have a two-ray model and like the basic, but later we have a Manhattan model. We can create our own mobility model, and definitely accordingly the interaction between two nodes, interaction between node and base station, and the nature of the channel fading, and everything is possible to realize. We have a lot of support when you took the source code of the appropriate region, you can do a lot of things, sir. I think as I said,
Okay.
the source
Instead, because say
Yes, sir.
when we select the area and we try to mimic that environment,
Yes, sir.
and after completion of the simulation, when we go to the site, the environment could have been changed.
Definitely, but at least we can expect all possible fading, everything you can induce, and see how best you can tweak the other configuration, so that if this happens in the real time, how you can able to mitigate. I think hope you that all these things are possible. Thorough revisiting the code and reconfiguring, readjusting, that is possible, sir.
Okay, thank you. Thank you very much.
I think I'm sorry. One more, madam asked something related to
Yes,
bandit.
sir.
Madam,
Yes, sir.
up to
Yes,
up
sir.
to up to NS 3.38. Up to that, we have a wave model, like the folder which I am showing. Likewise, here we have wave folder. Later, it became obsolete, so they are not no more going to use 802.11p. 802.11p wave wireless access for vehicular environment for a VANET that they were treated as obsolete. Now they are using cellular V2X, CV2X, madam.
Okay. Yes, sir. CV2X. Okay.
Yeah, you can use LTE based.
So CV2X, have they developed anything on CV2X?
No, we have to develop, madam. You as an application. This is the core model. What is existing
Okay.
LTE as a end use case? You can think of, as I said, no. You can take LTE, whichever the model, whichever the sample code, what we have inside model and example. You can take it to the scratch folder. Inside its folder, you have to paste and you have to design on our own, madam. The one which I've done, PANET. There are some demonstration I've done for other college where security related feature also DOS attack simulation we have done here. So likewise, you can develop a lot inside.
Okay, sir. And if I want to integrate Sumo with it
I
for
think
traffic,
we have a separate session. Probably I'll share the code steps to integrate Sumo with NS3, madam. So I think
okay.
I may have Sumo separately here. Let me check. I think I can you see, madam? Sumo-GUI.
Sumo. Yes.
Can you see my screen?
Sumo.GUI. Yes, I can see.
Yeah. So I think it will open, but I.
We are not able to hear you. Are you online? Anybody else is able to hear?
No, sir, no.
No.
No
No, sir.
from him.
No, sir.
No, sir.
I think his video also became standstill, sir.
Okay, we are calling him.
Hello. Hello.
Yes.
Yeah, I'm sorry. I got some. I got disconnected. Hello. Am I audible?
Yes.
Yes, sir, you are.
Yeah. So I'm sorry, some glitches, some memory over an error. So I tried to execute the smooth. So I think maybe I'll take it up in another session, maybe later, or if any time permits, as part of this FDP, I may borrow time from Sukumar Sir G. So maybe I'll show you demo Sumo with the NS3 later time. Sir is already waiting long. We are
Okay, sir.
All time yours. So basically, I can take any time also. Anyway, so do you want another slot for the session to continue?
Yeah, based on participants' interest, we may schedule maybe at the later time, sir. If they
Yes,
are
sir. It will be beneficial.
Definitely, sir, definitely.
Interest is already there. We can see a lot of interaction happening. So, how much time do you need for the next session to continue?
maybe like at least minimum 1.5 hours like that. I will talk to you over phone, sir. We will fix the date suitably in the later.
Okay. So we need to basically extend overall number of days to accommodate that, and perhaps we'll try and do that. Okay.
Yeah. Participants all, if they are okay, we can. Yes, sir.
Or maybe I can have another session at say 2:30 someday if people are interested. Like Saturday is you are booked. Saturday I have arranged a session related to how to install open source 5G core in any desktop or laptop. A hands-on kind of thing will happen on Saturday. So I'm already stealing a lot of time from you guys.
Yeah, that is also true, sir. Yes, sir.
Yeah. Okay, so
Then maybe in Saturday, in some in the latter hour, sir can give the session.
yeah. So that we'll try and do. Yeah, thank you. So,
Okay, sir. Thank you.
Madhukar, please offer a formal vote of thanks. I think you can speak here itself.
You said,
Sir, sorry, I have taken much of your time.
You can speak now. You are coming. Okay. So, am I audible?
Yes, sir.
Am I audible?
okay. So, eminent speaker Sri Vetrivelan sir, Sri Ashok Kumar sir, and participants, on behalf of entire team and all of the participants, we extend our heartfelt gratitude to Dr. Vetrivelan for a very nice presentation. It was very informative and touched upon many pertinent topics and also provided profound insight into the topic. He has provided clear perspective and explored into details of 5G network architecture, network slicing, as well as network simulator. Though it has not been completed, we look forward another session for to complete his presentation. And needless to say that a session of eminent speaker like Dr. Vetrivelan has significantly enriched our FDP program content. And we'd also thank and express heartful appreciation to passionate participants who are taking out their valuable time to make this FDP program participation interactive, fruitful, and successful. Thank you all of you. And shall I announce?
Yes, sir. Thank you very much, sir. So at an outset, I would like to thank DOT and the entire team who provided me this opportunity. Thank you. And at this juncture, I would like to extend my wishes regarding Ugadi, those who are celebrating. Happy Ugadi to all.
Thank you.
Thank you.
I
Thank you very much, sir. Thank you very much.
Thank you.
DGT ma'am is also here. Ma'am, if you like to say a few words before we start the next session, ma'am. Ma'am, your mic is mute. If you can unmute.
Okay, now I am audible.
Yes, ma'am.
तो सबको नमस्कार. आज के शुभ दिन का सबको बहुत बहुत शुभकामनाएं और
Very good morning,
बधाइयाँ.
madam.
आज पूरे देश में हर जगह पे हर रीजन में अलग अलग त्योहार मनाया जा रहा है और मैं ये कहना चाहूंगी इस अच्छे मौके पे कि हम लोगों का ये प्रयत्न कर्सी हमारी टीम छोटी सी टीम और डीओटी की हम कोशिश में है कि हमारे ज्ञान का प्रकाश भी 5G के एरिया में मोबाइल के एरिया में पूरे देश में पूरे इंस्टीट्यूट्स में आप लोगों के बीच में फैले. एंड आई एम वेरी हैप्पी टू सी द enthusiasm by each and every one of you in attending, in getting involved, in learning, in attempting the quizzes, and getting, you can say, enriched by the experience of all the learned speakers, faculty, and of course, our team members. Very happy and really feel indebted opportunities there for all of us to learn as and when. I also join whenever time permits, whenever some things are really very technical in nature, but I really appreciate the efforts being done by not only by our team, but all the faculty members of various institutes who are participating, not only in giving the lectures, but attending also and getting full advantage of it. Thank you and please keep it up. Ashok.
Thank you, ma'am. Thank you so much. And we see that you are always connected. That encourages us to like continue. So thank you so much, ma'am, for supporting us, encouraging us. Dear friends, we'll start our next session. Next session relates to dynamic spectrum sharing. That is some sort of coexistence of 4G and 5G using the same spectrum. Uh, uh, so please give me a moment to upload my PPT before I start. In the meantime, if Madhukar want to introduce about working group plan, which we have thought of to create working group among the faculty members to undertake certain activity. Madhukar, if you can just little bit speak about, but Monday we will provide this in detail. So go ahead, Madhukar. Take few minutes and do that.
First of all, I would like to inform the participants and the eminent speakers that we would be issuing letter of appreciation to all the speakers who has taken and volunteered to take the sessions. Secondly, we have another opportunity to contribute in this FDP program. We will be forming some working groups so that the participant can contribute and volunteer into the working group for the certain objective, which I will be presenting on Monday. And those will be very fruitful for the days to come. And this will have a definite impact on the industry and our field of electronics and communication and 5G technology. So I think by Monday I will present the full presentation on this one. And secondly, we would be announcing to have a compendium kind of thing. So all the 5G lab are getting set up in different institutions. So we would be expecting the institutions so that they can narrate their success story, and we will compile them and release them as a compendium. So on both the topic, I will be presenting the final steps and activities. So that's what I want to announce. So Monday will be the important day for this presentation. So I'm taking this few days time to finalize this. Thank you.
Okay, so let me upload my PPT. So please confirm if my PPT is visible and my audio is clear to all of you.
Yes, sir.
Yes, sir. Perfect.
Thank you. Okay, so